Hello everyone. Just a quick question. How many of you have heard of diabetes? Just raise your hand. Wow, almost everyone. It's not surprising. Diabetes is a common but serious disease. In the United States alone, over 38 million people are living with it, and the number is still climbing. Diabetes comes in many different types, but all of them have one thing in common: too much sugar in your blood. But wait, don't we all need sugar? Absolutely. We all need sugar or glucose for energy, and we get it from the food we eat. After a meal, our body breaks down carbs into glucose, which then enters our bloodstream. But here is the thing. To actually use the glucose for energy, we need something to unlock our cells. And that key is a hormone called insulin. Insulin is produced by a group of cells in your pancreas called beta cells. If you don't have diabetes, these cells function well. They can sense the glucose level in your blood and release just the right amount of insulin to keep everything in check. However, with diabetes, the system doesn't work as it should. Your body either cannot produce enough insulin, or the insulin it does make cannot function well. As a result, sugar builds up in your blood, and that's where all the trouble starts. So, what makes these cells go on strike? Well, a big factor is your diet. Diet always plays an important role when it comes to diabetes. If you are regularly taking too much sugary and fatty food, you are putting yourself at risk. Over time, this sugar and fat can seriously stress out your pancreas, especially those hard-working beta cells. So, what happens to these cells under the stress? That's where my research comes in. And here is what we did. We took the cells, including the superstar beta cells, from human pancreas and grew them in the lab. And later, these cells were exposed to different conditions, some normal, some overloaded with sugar and fat to mimic an overnutrition environment. And then it comes to the cool part. We use cutting-edge techniques which allowed us to label each cell individually so we can track down what genes are on or off under stress right at the single cell level. It's like we sat down to have a one-on-one conversation with each cell and asking them, hey, how are you holding up under all this sugar and fat? And every cell has a story to tell. And by putting all the words together, we get a clear picture of what's going on. And we did not only talk to a few cells. In fact, we analyzed over 90,000 cells and built the first detailed map of how the human pancreas responds to overnutrition. And here is the map. On this map, each dot represents a cell, and every piece of the conversation has been documented here. I know what you're thinking now. Oh, great, 90,000 cells, a fancy map. Sounds like I'm going to win the scientific fair of the year. But why does all this matter to us seriously? Well, we have already known beta cells, which produce insulin, are the key to control the blood sugar. But what we did not expect is the surrounding neighboring cells. They are also playing an important supporting role. In fact, these cells form strong interactions with beta cells, but under overnutrition, these connections got weakened, which means the teamwork starts to fall apart. And this gives us a fresh insights. Beta cells are not walking alone. So why should we only focus on them for diabetes treatment? Maybe it's time to think bigger. Imagine a cocktail therapy which boosts not only beta cell, but the health of the whole team. And this could really transform how we tackle diabetes and open the door to much more efficient therapies for patients. And that's a hope we are all working towards. Thank you very much.